Trying to freak you out, but I'm not exaggerating the dangers to your network security either. Here's an example. Recently I hooked up a friend's computer to a high-speed network connection from his phone company. He had antivirus software but no personal firewall in place yet. Before he could get the firewall set up, which usually takes about 10 minutes, 15 virus alerts popped up. Although viruses are common threats that we hear all about, there are other nasty things out there as well. Bad guys who create threats to a network generally have one of two purposes in mind: destruction or reconnaissance. They're seeking to destroy or deny access, or maybe even nick information that you definitely don't want them to have. Some types of attacks can accomplish both, but they're usually combinations in simpler forms. In the following sections, we'll look at several common approaches that bad guys use to breach the security of our precious networks. Denial of service, DOS attacks, does exactly what it sounds like. It would do. It prevents users from accessing the network and their resources. Today, DOS attacks are commonly launched against major companies' intranet and especially its websites. Joe the hacker, formerly a plumber, thinks if he can make a mess of, say, Microsoft or Amazon's website, he's done that company some serious damage, and you know what, he's right, even though the DOS attacks are nasty. Strangely, hackers don't respect other hackers who execute them because they're really easy to deploy. It's true, even a pesky little 10-year-old can execute one and bring you to your knees. That's just wrong. This means the real bad guys have no respect for someone who uses DOS attacks, and they usually employ much more sophisticated attacks of wreaking havoc on you instead. I guess it comes down to that honor among thieves thing. Still know that even though a DOS attack won't gain the guilty party any esteemed status among real hackers, it's still not exactly a day all the beach to deal with. Worse, DOS attacks come in a variety of flavours. Let's talk about some of them now. Ping of death. Ping is primarily used to see whether a computer is responding to IP requests. Usually when you ping a remote host, what you're really doing is sending 4 normal sized Internet Control Message Protocol ICMP packets to the remote host to see if it's available. But during the ping of death, a humongous ICM packet is sent to the remote host victim, totally flooding the victim's buffer and causing the system to reboot or helplessly hang there drowning. It's good to know that patches are available for most operating systems to prevent a ping of death from working. Unreachable Gateway. An attacker can make a host's default gateway unreachable. The end game is to get the host to change their gateway address to that of one controlled by attacker to accomplish a man-in-the-middle attack. First, the attacker tries to take control of the secondary gateway available to host shown in G1 in figure 141. 2. The attacker, acting as the destination host, sends a TCP open packet to the acting source host. 3. While a reply is in transit from the source host to the destination host through gateway G2, the attacker sends a spoofing as G2 sends an ICMP route redirect message to the source host. 4. The source host will accept the route change control message as valid and does change its routing table to route all traffic bound to the destination host through gateway G1. Now the attacker, acting as and man in the middle host will quietly read, modify and forward all traffic bound to the destination host to G2. Distributed denial of OS. Denial of service attacks can be made more effective if they can be amplified by recruiting helpers in the attack process. In the following sections, some terms and concepts that apply to a distributed denial of service attack are explained. Botnet. A botnet is a group of programs connected on the internet for the purpose of performing a task in a coordinated manner. Some botnets, such as those created to maintain control of internet relay chat (IRC) channels, are legal, while others are illegally created to foist a DDoS. An attacker can recruit and build a botnet to help amplify a DOS attack, as illustrated in figure 14.2. Okay. The steps in the process of building a botnet are as follows. 1. A botnet operator sends out viruses or worms whose payloads are malicious applications. The bots infecting ordinary users' computers. The bots of the infected PCs log into a server called a command and control CNC server under the control of the attacker. At the appropriate time, the attacker, through the CNC server, sends a command to all bots to attack the victim at the same time, thereby significantly amplifying the effect of the attack. Traffic spike. One of the hallmarks of a DDoS attack is a major spike in traffic in the network, as bots that have been recruited mount the attack. For this reason, any major spike in traffic should be regarded with suspicion. A network intrusion detection system (IDS) can recognize these traffic spikes and may be able to prevent them from growing larger, or in some cases prevent the traffic in the first place. Some smaller organizations cannot afford some of the more pricey intrusion prevention systems. IPS or IDSs make use of features present on their load balancers. Many of these products include DDoS mitigation features such as TCP/SYN cookie option. It allows the load balancer to react when a number of SYN requests reach a certain point. At that point, the device will start dropping requests when the SYN queue is full. Coordinated attack. Another unmistakable feature of a DDoS attack is the presence of a coordinated attack, as shown in figure 14.2, as just described in the section Botnet. To properly amplify the attack, the bots must attack the victim at the same time. The coordination of the bots is orchestrated by the command and control server depicted in figure 14.2. If all the bots can be instructed to attack at precisely the same second, the attack becomes much more dangerous to the victim. Friendly unintended DOS. An unattended DOS attack, also referred to as attack from friendly fire, is not one that is not caused by malicious individuals. Instead, it's a spike in activity to a website or resource that overpower its ability to respond. In many cases, it's the result of a relatively unknown URL suddenly being shared in a larger medium, such as a popular TV or news show. For example, when Michael Jackson died, the amount of Twitter and Google traffic spiked so much that at first it was thought as an automated attack that was underway. Physical attack. Physical attacks are those that cause hardware damage to a device. These attacks can be mitigated, but not eliminated, by preventing access to the device. Routers, switches, firewalls, servers, and other infrastructure devices should be locked away and protected by strong access control, otherwise you may be confronted with a permanent DOS covered in the next section. A permanent DOS attack is one in which the device is damaged and must be replaced. It requires physical access to the device, or does it? Actually it doesn't. An attack called a flashing denial of service (PDoS) attacks the firmware located in many systems. Using a tool that fuzz introduce errors, the firmware attackers cause the device to be unstable. Another approach is to introduce a firmware image containing a Trojan or other types of malware. Smurf. Smurfs are happy little blue creatures that like to sing and dance, but a Smurf attack is far more nefarious. It's a version of a DOS attack that floods its victims with spoofed broadcast ping messages. I'll talk about spoofing in more detail later. For now, understand that it basically involves stealing someone else's IP address. Here's how it works. The bad guy spoofs the intended victim's IP address and then sends a large number of pings, IP echo requests, to the IP broadcast addresses. The receiving router responds by delivering the broadcast to all hosts in the subnet, and all the hosts respond with an IP echo reply, all of them at the same time over the network with hundreds of hosts. This results in a major network gridlock because all the machines are kept busy responding to each echo request. The situation is even worse if the routers have not been configured to keep these types of broadcasts confined to the local subnet, which thankfully they are by default. Figure 14.3 shows a Smurf attack in progress. So the attacker sends IMP broadcast to the network with false IP address, internet. Network overloads victim with ICMP response. Fortunately, Smurf attacks aren't very common anymore because most routers are configured in a way that prevents them from forwarding broadcast packets to other networks. Plus, it's really easy to configure routers and hosts so they won't respond to ping requests directed towards broadcast addresses. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.